Temperature dependence of solubility of solutes in water. As we mentioned before, there's a strong temperature dependence of the solubility limit. Generally, it's given in grams of solute to dissolve in 100 grams of water. For most solids, the solubility of the solid increases as the temperature increases. And this is probably something you've seen just by cooking. Like if you're adding sugar to something, or you're making a brine of turkey, if you need to heat that brine up or heat that sugar solution up so that the sugar dissolves, like if you're making candy, for example. And this is typical for most solids. Generally, it happens when the heat of solution, when the heat of solution is endothermic, and the solubility curves can be used to predict whether a solution with a particular amount of solute dissolved in the water. A solubility curve would just be the solubility as a function of temperature. So you could use that to predict whether a solution with a particular amount of solute is going to be saturated, unsaturated, or supersaturated. So here's an example of some solubility curves. You can see it's a little complicated to see to tell why things are behaving in the way they are, and we'll get to some more quantitative behavior later. But what you generally see is that they do generally increase in solubility with temperature. So generally, if the heat of solution is endothermic, then the solubility will go up with temperature. And that's generally the case for a lot of ionic solids. And if the heat of solution is exothermic, then the solubility goes down with temperature. I mean, right now, this is just something you memorize. Later in the semester, we'll learn why this is the case. Yeah, we'll come back to that. So purification by recrystallization. So a common way to, one of the common operations performed by chemists or chemical engineers is removing impurities from some solid compound. So one common way to do this involves dissolving the solid in a hot solvent until the solution is saturated. And then as the solution cools, the solid crystallizes out, leaving the impurities behind. And so that's actually a really useful way to perform purifications. It's preferred to a lot of things like distillation because it uses less energy.